All right, so in this problem, we're going to solve an absolute value equation. So you can see in this problem, we have an absolute value term. We have 2 times the absolute value of 5x plus 1. I'm going to go ahead and just kind of box that in. So this is the term, that's the absolute value. The first step that I'm going to take in this process, always, is I'm going to isolate, let me try a different one there, isolate the absolute value term. So I'm going to isolate the absolute value. So in this case, I have an equation. I'm going to get that absolute value 5x plus 1 by itself. So in this case, I'm going to add 9 to both sides. That's going to give me 2 times absolute value 5x plus 1 equals 4x plus 26. So still trying to get that by itself. So I'm going to go ahead and I'm not going to distribute this 2 in. I'm not going to multiply that 2 in this case. I'm just going to go ahead and divide everything by 2. So I'm going to divide the left-hand side by 2, which will give me 5x plus 1. And then on the right-hand side, I'm going to divide each term by 2. So that's going to give me a 2x plus a 13. So I did that first job. I'm going to isolate or get by itself the absolute value term. Now the second thing to do is we're going to create 2 equations from here. We're going to create 2 solutions. Create 2 equations. Okay, because an absolute value is a distance. An absolute value you can think of as a distance from a certain point. And so if I'm looking at a certain distance from a point there, and you think about the number line, there's going to be 2 different possibilities there, right? If I say, what's the absolute value of 5 or negative 5, they both have the same distance from 0, right? So in the same way, we're going to take this and create 2 equations. So the first equation is just going to be the same setup. I'm going to say 5x plus 1 equals 2x plus 13. The second equation, I'm going to say 5x plus 1 equals, so I'm going to think of this as kind of reversing this equal sign, okay, which is still an equal sign. And then I'm going to take the opposite of the right-hand side. So I'm going to take the opposite of 2x plus 13. 2x plus 13. So of course that second equation is going to be 5x plus 1, and then the opposite of 2x plus 13, if we distribute, is negative 2x minus 13. So these are my 2 possibilities here. I have this equation, which is going to give me one answer, and I have this equation, which is going to give me the second answer. So basically we just have to solve these 2 equations. So starting with the one on the left, I'm going to subtract 2x, and I'm going to get 3x plus 1 equals 13. I'm going to subtract 1 and get 3x equals 12, and then divide by 3 to get x equals 4 is an answer. And then same thing with the one on the right. I'm going to add 2x to get it to one side. I'm going to get 7x plus 1 equals negative 13. I'm going to subtract 1. Going to get 7x equals negative 14. And then divide by 7 to get x equals negative 2. So I create 2 equations, and then especially that second equation, what are we doing with that second equation right here? I'm just going to put a little asterisk here, and I'm going to say reverse symbol and take the opposite. reverse symbol and take the opposite. So what I mean by reverse symbol, it doesn't really do much with an equation. So if you think about the equals sign, if you reverse that symbol, it's going to stay as an equal sign. And I just use that term because once we get to inequalities, then we can sort of just remember this rule to solve any sort of absolute value equation or inequality, because we're going to do the same thing. So we isolate the absolute value, and then we create two equations which give us two solutions, and there are solutions. So we have 4 and -2. Now it does say to check your solutions. Checking your solutions, of course, is just going to mean take your answer, substitute it back into the problem, and then make sure that it checks out. So I can plug it back into the original. I can also just plug it back into this one right here. So I'm going to go ahead and check them with this one right here. So if I check x equals 4, that means I'm just going to substitute 4 into x. So let's go ahead and do that. If I plug a 4 in here, let's just make sure that this is true. So this would be the absolute value of 20 plus 1 equals 8 plus 13. The absolute value of 21 equals 21. And yep, that makes sense, right? That means that 21 equals 21. And that's good. If I'm going to check the x equals -2, let's do the same thing. So I'm going to have the absolute value of 5. I'm going to plug in a -2 there instead, right here. And then I'm going to evaluate and check it. So I'm going to have the absolute value of -10 plus 1 equals -4 plus 13. So I have the absolute value of -9 equals +9. Now, is that true? Well, the absolute value of -9 is a +9, so this would evaluate to +9, and that, of course, does equal +9, so that is still true. So both of these are true. If for some reason one of them was false, right, you could get an extraneous solution. So if you see that terminology, you get two answers, but then one of them does not check out or does not evaluate to true, then you can label it as extraneous, and it really isn't a solution at all. It does say to graph the solution set, so if I had to graph this, I'm really just going to use a number line here and just basically say, all right, if that's 0, I got 1, 2, 3, 4. My two answers here would be at, here's 1 right here at 4, and here's at -2. I could just plot them on a number line. So again, our steps here: isolate the absolute value, create two equations, reverse the symbol, take the opposite for that second one, and then basically I'm going to say solve both. Okay, step 4, if there is one, is going to be check answers. And that's the basics of taking any equation that has an absolute value, and that's how you're going to solve it. You're going to follow those steps.